Education, education, baby. Come on, education has no end. Education.
Hello students, how are you today? Welcome to our today's lesson on the topic of structure and bonding, and we are going to specifically look at the ionic bond. Welcome, and let's begin. A structure is the arrangement of particles, while bonding is the forces which hold the particles together. Therefore, for a structure to be firm, it must be held together by forces. And these forces are the ones which we call bonding. You can just imagine of a structure of either a house, a structure of a construction site. And looking at it, you look at the structure. Maybe the particles arrangement. For example, the bricks, the way the bricks are arranged. And then there is what is holding the bricks together in position. Those are the forces. In this case, we use concrete to be able to hold the bricks together in a structure. Now, the same thing applies to chemistry. A structure is the arrangement of particles. These particles can be of any shape, and the particles must be held together by forces of attraction. The forces in this case, we call them bonds. And we are going to look at different types of bonds and the type of structures they form. Types of bonds and related structures. We have different types of bonds. We have, for example, the ionic bond, which forms giant ionic structures. The name of structures formed from an ionic bond are giant ionic structures. We have the metallic bond, which forms structures called giant metallic structures. We have the covalent bond, which forms two types of structures. Now, if the covalent bond is between atoms, then we form giant atomic or covalent structures. Then if the covalent bond is between molecules, then we form simple molecular structures. Those are the main types of bonds that we have. Now, other bonds which we are going to look at are the dative or coordinate bond. We shall mention that bond at some point, but it is not a main bond. It is just part of a covalent bond, which is also part of what we are supposed to cover. Ionic bond and the giant ionic structure. We have said at the beginning that we are going to mentally deal with the ionic bond and the structure it produces, which is a giant ionic structure. Now, some factors about the ionic bond is that it's usually formed between a metal and a nonmetal. It involves complete transfer of electrons, whereby the metal loses electrons and the nonmetal gains those electrons. Then the metal loses electrons to form positively charged ions or the cation, while the nonmetal gains electrons to form negatively charged ions. Those are the anions. The resulting oppositely charged ions attract each other, forming a strong ionic bonding. For example, the formation of magnesium fluoride. Magnesium is a metal, fluorine is a nonmetal. Therefore, magnesium loses electrons while fluorine gains the electrons, and therefore they become oppositely charged, and then the attraction between the opposite charges is what comprises the ionic bonding. Now, here is a diagram of how magnesium fluoride is formed. We have magnesium, one atom of magnesium, losing the two outermost electrons. Each electron goes to a fluorine atom. Each of the electrons is transferred into a fluorine atom as shown in the diagram. Now the result is a magnesium ion with 2 positive charges and 2 fluorine ions with a negative charge each. Therefore, now the attraction between the positive charges and the negative charges of magnesium and fluorine encompasses the ionic bond as shown. So you can see at the point where the ionic bond is formed. Now, formation of magnesium chloride. Magnesium is a metal, chlorine is an nonmetal. So the two can form an ionic bond. We have chlorine. Okay, let me start with magnesium. Loses 2 electrons to attain a stable structure of 288. While chlorine, which has 287, gains an electron and another chlorine atom gains an electron, so that we have them having a stable structure of 288. Now, the chlorine remains with a negative charge while the magnesium remains with a positive charge. The chlorine atoms are 2 of them, so we shall just write 2 at the beginning and put just a single negative charge, but meaning 2 atoms of chlorine. While magnesium has a positive charge of 2 positive. Therefore, the charges cancel each other or attract each other to form the ionic bonding. So that is how the ionic bonding is formed between magnesium and chlorine. There are some points to note about the ionic bond. One of them is that all electrons must be shown, not only the outermost ones. All electrons must be shown. Number 2 is that ionic bonding involves complete transfer of electrons. You can see the electrons are being transferred from one atom to another. So it involves complete transfer of electrons and not sharing. No sharing at all. The electrons are completely transferred from one atom to another. The giant ionic structures. Now, earlier on we said that ionic bonding produces giant ionic structures. Now, these structures are ionic in nature and they are 3-dimensional in shape. An example is sodium chloride. Each sodium ion is surrounded by chloride ions, and each chloride ion is surrounded by 6 sodium ions, which are equidistant from each other. This leads to formation of a 3-dimensional structure. Now, properties of giant ionic structures. One of them is that they are usually solids at room temperature. They have high melting and boiling points due to the strong ionic bond. They are soluble in water and insoluble in organic solvents. They are crystalline in nature. They are good conductors of heat and electricity in aqueous and molten state, but not in the solid state. This is because aqueous or molten state, the ions are mobile, but in the solid state, they are fixed. Now, this question normally troubles students in exams, whereby they end up saying that ionic structures do not have ions in the solid state, which is very wrong. They have ions. It's only that they are immobile or they are fixed. They cannot be able to move from place to place to be able to conduct electricity. So note that. Now that marks the end of our lesson. Hope you've been attentive enough and you have been able to understand every point. Let us meet again in the next lesson. Cheers.
Education, education, baby. Come on, education.